Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports the show on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the life cycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. You can reach me on Twitter at podcastinit or email me at hosts@podcastinit.com. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host, as usual, is Tobias Macey, and today I'm interviewing Alex Grönholm about the Asphalt Framework, a Python microframework for network-oriented applications. So, Alex, could you please introduce yourself?
Hi, everyone. My name is Alex Grönholm. I'm a software engineer. I've been writing code for almost my whole life now, I guess. I've been working professionally as a software developer since 2005. My first job was writing PHP code, actually. That lasted 6 months, during which time I developed a very passionate hate for PHP. After that, I moved on to Java, that enterprise Java. I wrote an enterprise resource planning software during the next 2 years. Java was a lot better than PHP, obviously, but I found it a bit clumsy and cumbersome and verbose. So when I finally found Python, it was pretty liberating.
And do you remember how you first came across Python?
Yeah, many years before I actually started with Python, I had heard about it, and I had heard that it had the kind of grammar where white space was significant, and I found it intriguing. But it took many years before I actually started using it. And when I picked it up, I found it really easy, like the easiest programming language I've ever learned. In less than 2 hours, I had already made my first practical application. So I found it really impressive that a language could be learned so easily.
And you ended up using Python for building the project we're talking about today, which is the Asphalt Framework. So I'm wondering if you can just discuss briefly what Asphalt is and what your reason was for building it.
Yeah, the thing is, when I was building this enterprise resource planning software, I ended up using tools other than HTTP for communication. And I found that there are no application frameworks at all for writing non-web apps. So I would have had to use something like Twisted or Tornado. Actually, I ended up using Tornado for it. But really, you just can't find generic extension components. Like, Twisted is a low-level networking framework. It's not really an application framework per se. So that bugged me. It bugged me that there's no such thing available, in contrast to Enterprise Java, where you do have such a thing. I ended up trying to build that framework. I wanted to build a framework that would serve everyone's needs, not just the web developers' needs. So you could use the same extension components for any kind of application, starting from command line tools to really complex multi-protocol applications. So you could do whatever you want without having to switch tools. And that was my goal.
And you mentioned that the sort of main differentiator between Asphalt and Twisted is the fact that Twisted is so low level, whereas Asphalt gives you a lot of higher level primitives for being able to compose an application.
Yeah.
So
Asphalt is an application framework, whereas Twisted is a networking framework. really. I think the only common thing between these two is that they both have an application runner, which reads configuration and then starts an application. But really, Asphalt was meant for building components from which you compose applications.
And one of the really appealing things about Asphalt is the fact that it is purely asynchronous throughout the entire stack, and looks like it takes advantage of the new async I/O capabilities in the Python 3 runtime. Mm-hmm. So just curious if you can explain your reasoning for that heavy focus on the asynchronous capabilities and what that gains you for the particular type of applications that you're looking to build with Asphalt.
I really meant Asphalt to be the one framework to end them all. So the reason I picked async I/O was, first, because async I/O is part of the standard library. I needed some kind of a networking stack underneath it. So the choices were either using Twisted or Tornado or some other async framework for it, or I could have gone to the threaded route and do like a Flask or a Pyramid or Django or you name it. But the thing is, sometimes you do need async. For example, when you have tens of thousands of concurrent connections. And the thing is, if Asphalt was based on blocking code threads, it would be pretty difficult to add this async capability into it. So I figured the best base would be async I/O because, well, as I said, it's in the standard library. And there are pretty good facilities for running blocking code from within the event loop, but you can't really do it the other way around. It's pretty difficult. So that's why I chose async I/O.
And what are some of the most challenging parts of writing asynchronous code and event-based applications, and particularly making the entire stack asynchronous? And how does Asphalt help with enabling people to be able to write those kinds of applications?
Yeah, the fact is that multitasking is difficult, no matter how you put it. If you're using threads, there are some advantages and disadvantages, and the same applies to cooperative multitasking. Like with async I/O, there are always pros and cons to everything there, but it's difficult no matter what you do. So Asphalt has a few things that will make life easier for writing code in the async or threaded manner. For example, if you need to access libraries that work in blocking mode, use file I/O or blocking networking code, then Asphalt has a few methods that you can use to easily run code in worker threads, and likewise it has functions that enable you to call on the event loop from worker threads. So sometimes I write my applications in a way that I run most of the functions in worker threads, but then sometimes I end up having to call some coroutine or some code that really needs to run on the async event loop. Then I have this thing called call async, which pretty much suspends the worker thread until the function call is done on the event loop. The async I/O library doesn't really offer something like this out of the box. It has something like run coroutine thread safe, but you have to know that the code is a coroutine. Call async runs whatever code, even if it's a plain function or a coroutine function. It doesn't care. It will run whatever async code you want in the event loop.
And when you're pulling in third-party libraries to use in your application, it's all too easy to pull in some libraries that don't work properly with async capabilities. So what are some of the techniques for being able to identify some of those blocking portions of the code and resolve them by either wrapping them in an explicit thread or making them async compatible?
Identifying them is the easy part. Usually the libraries that are written for async I/O, they quite prominently display it. So you will see in the documentation and examples where they use async and await. So that part's not hard. When you encounter a library like, say, SQL Alchemy or Exchange Lib, then usually you have to find which functions will block and which ones don't. That's pretty much the hard part. So when you know that this function call will cause file I/O or blocking network I/O, then there are several techniques you can use to wrap that code, to call to that code. One is the call in executor call that Asphalt offers. You just pretty much do a await call in executor, and you give the function and these arguments as arguments to that function, and you await on the result. Another technique that I'm actually pretty proud of is the async with thread pool approach. So what this does is that you have a coroutine function, and inside this coroutine function you have an async with block inside which you put the blocking code. So when the execution enters this block, it adjourns the task, the async task that is running, and it switches to using a worker thread until the block is done, at which points the execution resumes on the function in the event loop. It's something I've never seen before anywhere else, and it makes mixing blocking code and async code much more natural. And Asphalt has some component projects that wrap these services in easier ways for the consumer to use.
So what does the internal architecture of Asphalt look like, and how has that design evolved from when you first started working on it?
There are a few basic building blocks in Asphalt. I think I should start with components. Components are something that they are classes which are used for adding resources. Basically, when an Asphalt application starts, it always starts from a root component, and this root component can then start other components and so forth. Components pretty much they launch services, and they add resources to a context. And these resources are typically services like, say, a mailer service or a database connection or anything. A resource can literally be any object of any type. So when these resources are added to the context, then other components can request these resources. So you can build a component that depends on services provided by other components. You can build a pretty large hierarchy of these complex services built on simpler services this way. And you can also build independent sub-hierarchies of components this way and combine them. For this reason, context can be stacked so that you can have multiple levels of context. A child context can access resources from its parent context, but not vice versa. This is for the purpose of isolating the smaller independent parts so that they don't interfere with each other. Yeah, that's pretty much the core. Yeah, but you ask other questions too, how does that evolved during my development? In the earlier stages, the code was, of course, in quite a flux. So the problem was that nobody had really tried to do this in the Python space, so I didn't know what was the right approach. So Asphalt has had a number of breaking changes in its history, mostly related to the context and especially context teardown, because one part I neglected early on was the teardown process. When an application shuts down, it needs to shut down the services as well in an orderly manner. And I think it was 3.0 where I actually managed to fix that. And also one issue that I haven't fully resolved yet is the startup processes where there is a timeout, but some services may require additional time to connect to network services and so on. So it's difficult to know when the launching of a component has actually stalled or if it needs more time.
And one of the things that you mentioned in there was the ability to maintain context for a particular async task. And one of the PEPs that's currently being discussed is PEP 550 for context local variables that will be somewhat akin to the thread local variables that frameworks like Flask and Django make such heavy use of. So I'm curious how much that is going to simplify or benefit the work that you've been doing with Asphalt as far as that particular problem.
Yeah, I've been following that development with interest. The thing is, if I were to adopt this approach, I would have to introduce a breaking change to Asphalt. But yeah, I have run into situations where that would have been beneficial. Like when you have SQL Alchemy listeners, then injecting the current context is quite cumbersome. I've done it, but it's difficult. And if you are using a library that requires similar things and you don't have the benefit of a ready-made component project for it, then it's going to be quite difficult without the context local variable or task local variables. Also, there's this issue of threads because Asphalt relies quite heavily on worker threads to access those blocking libraries. So I'm not sure. I can't really recall how this PEP works with threads, but of course the thread would need to know which task it's tied to, and that presents additional problems. Also, there's this thing in the Python Zen about explicit being better than implicit. So I really like the way Asphalt works currently, passing the context object around. Sometimes it may be cumbersome, but it really is explicit, and I think it helps with testing. It makes things so much more explicit, really, and easier to reason about, at least in my opinion. But yeah, it's something I may consider adopting in the future.
And going back to the component-based nature of Asphalt, there are a pretty impressive number of integrations that you've built up for it in the GitHub organization. And I noticed that there are a couple of them that you've got in there as placeholders, such as the Asphalt bridge for being able to bridge between Asphalt instances. So I'm just curious if you can give a high level of some of the ones that you're most proud of or find most useful, and some of the ones that you would like to be able to start work on or have some additional help with.
Yeah, I would totally love to have a lot of help with this project because I just don't have time for all of them. Yeah, about Asphalt Bridge, that's my most ambitious component project for Asphalt. The idea behind Asphalt Bridge was that you could actually bridge to Asphalt instances so that you could have one Asphalt instance running on another machine requesting resources from another Asphalt instance. So you could have you could scale horizontally, and you could have a network of services. You wouldn't have to care where the services have actually been published. You could just network your Asphalt things and just request resources as usual and not care where they are provided. And they would use some form of RPC for communication. Obviously, you can't do this with all kinds of resources. Like, for example, database connections might not be a good fit for this, but things like a mailer service would. So you could have a mailer service abstraction. You would have an application that would request a mailer, and another machine would provide the mailer service. You could have it use either SMTP, maybe on any server, and then you could just switch it to SendGrid implementation, and the component that dependent on this mailer would not know the difference. There's just a mailer that works, and it doesn't care how it works. And so the other project that I would really love to complete is there's this thing called Asphalt Scheduler. It's really high on my priority list. I just haven't had any time for it lately. Are you familiar with AP Scheduler?
I am, yes. I was actually looking at your GitHub profile while I was preparing for the show and noticed that you were the author of that, and I actually made fairly heavy use of that in one of my early Python projects. So thank you very much for that as well. It's quite a useful project.
Yeah, no, you're welcome. So Asphalt Scheduler is pretty much a redesign of AP Scheduler as a native service for Asphalt. It reuses much of its code, but of course it's vastly improved. Asphalt Scheduler lets me do a lot of nice things. I have this almost finished project called Asphalt Feed Reader, which is a library for reading RSS and Atom feeds, and it also has backend which lets you fetch any arbitrary pages and produce RSS-like events from them. And that's really neat, but it needs some kind of scheduling component to it. And initially, I set out to duplicate some of AP Scheduler functionality for it, but then I realized that I really need to do this in its own scheduler library because it would be duplication of effort. So that's just one thing where I would need scheduling. I think the GitHub project where that code was supposed to go is named Asphalt Tasks. It's named that way because I initially intended to combine a scheduler with a task queue, like with Celery. But I found out that the scope of this project was too broad. So I figured that my next best step would be to just take the scheduler part and implement that as its own library to get going with that, because most of my tasks, as I found out, are really simple coroutine based stuff. Actually, you can use Asphalt Scheduler for that, but AP Scheduler, but its coroutine support is not the greatest, and I mean, it does work with coroutines, but it was pretty much added as an afterthought, and it doesn't integrate very well with Asphalt because Asphalt has this asynchronous signaling event system, which was pretty much copied from the Qt library, and it doesn't. AP Scheduler has its own event system, and I really didn't want to mix these two systems together, so that's one reason why I wanted to make Asphalt Scheduler as its own thing rather than integrating AP Scheduler. Also, the thing I've been working on this weekend is Asphalt Web. The funny thing is that although I've been using Asphalt in production for a year, anyway, Asphalt Web provides web application support for Asphalt. The reason why I haven't been talking about Asphalt in public so much is that Asphalt doesn't really cater to web developers, and that's something I wanted to fix first before I really start marketing it. So I needed a web framework that would truly integrate with Asphalt. For example, Asphalt has these serialization and templating components, and I wanted the web component to integrate with those two. And while I've been experimenting with creating REST services on top of Sonic with some glue code to make it work with Asphalt, they don't really integrate that well. So that's why I'm working on Asphalt Web as its own standalone project instead of integrating, say, Sonic into Asphalt.
And what have been some of the most difficult aspects of building and growing the Asphalt framework and its capabilities?
I would have to say that it's because Asphalt breaks new ground in a lot of ways. So I have had very little feedback from people because, as I found, people don't really have anything to say. They go on like, I don't know how any of this works, so I can't say anything about it. So it's been pretty hard to get reasonable feedback for the things I've done with Asphalt, because there are not really no frameworks like this in the Python space, and I think that's the most difficult part, because you do a design and then you can't know for sure if it's correct and what problems will I be facing later on. So that's given me a lot of headache.
And what are some of the most interesting or unexpected uses or projects with Asphalt that you have seen or done?
I haven't heard that much back from people using Asphalt. I know there are people who use it, but they don't really talk to me that much about it. So I can tell you some things I've done with Asphalt myself. For example, I have this work project where I use Asphalt for IoT gateways, and what they do is they read stuff from the serial port. They do some processing on it, and then they use WAMP, short for Web Application Message Protocol, a WebSocket subprotocol. They use WAMP to publish messages on the WAMP router, where then another application, also Asphalt based, picks up these messages and saves them to the database. And they are also published to web-based clients, which see the events in real time. So I think that qualifies as interesting.
Yeah, the WAMP protocol is definitely something that I found interesting as well. And I actually had Tobias Oberstein on the show a little while ago to talk about his work with Crossbar and developing that protocol. So I was amused and interested to see the fact that you had built a component for Asphalt to be able to take advantage of that protocol as well. So it's definitely cool to hear about it being used in real world use cases and integrated with Asphalt for being able to provide sort of a real time equivalent to the Unix T for a data stream.
Yeah, I haven't run across anything comparable to WAMP. I think that most users of WebSockets do this. They implement the RPC or pub/sub on their own, which is actually what I did first before I learned about WAMP. As I mentioned before, I had this enterprise resource planning software that I made, and I also based a later version of it on WebSockets, and I had implemented a custom RPC protocol and pub/sub system, but it was a lot of work and I really didn't want to maintain something like that. So I asked myself, hasn't anybody done the same? And then I started looking and I found WAMP. So I was pretty glad to find something that was already done, something like a standard on which I could build. So I fully embraced WAMP for all the projects that I do.
And what are some of the new features or improvements that you have planned for the future of Asphalt, or some components that you would like to see people build and contribute to the project?
Oh, where to begin? Some of these I mentioned already. The scheduler part is really important for me. I actually needed a scheduler in all of my work projects, and I have something suboptimal implemented in each one of them, and I really love to have a working fully featured scheduler in all of them. And obviously having a web component is really important for the future of Asphalt. Also, as I mentioned, Celery, I think Asphalt needs integration or a native component that lets you queue tasks, because a lot of these tasks that need to be that applications need to run are CPU intensive, and doing that in threads is suboptimal. So yeah, definitely something like that I would like to have. Also, BitTorrent support would be great, because have you heard of this project called FlexGet?
I think I may have heard reference to it briefly, but I'm not terribly familiar with it, if you'd like to explain.
Yeah, FlexGet is like a downloader framework. It can pull websites for new things. Think of like downloading new episodes or movies or whatever. It can pull websites and then automatically start downloads for the things you care about. It's really, really cool. And I figure that a good proof of concept for Asphalt would be to have all the components necessary for that, and then build a FlexGate-like application for Asphalt.
And one question that I forgot to ask earlier is, what's the story behind the name that you chose for the project?
Yeah, the thing is, there's a slogan for Asphalt, paving the way to the future. So I thought that Asphalt was a metaphor for having a framework that lets you focus on the application instead of the integrations and whatnot. So you could just slap components together and focus on the business logic. So it's like a difference between driving a bumpy road and then a smooth road made with asphalt, if you understand the meaning.
Yeah, no, definitely. It's I assumed that it was something along those lines, so it's good to hear sort of the reasoning behind it. And are there any other aspects of the project or anything related to it that you think we should talk about before we start to close out the show?
I think we covered the most important parts at least. I can't think of anything else.
And one other thing that I thought that we should probably mention is that, as I noticed in the documentation, because of the fact that Asphalt is built on top of Async.io, it is compatible with the UV loop engine for being able to get some pretty impressive performance out of the actual runtime.
Yeah, hopefully. In fact, Asphalt supports more than just UV loop. It supports AIO-G event and the new Rust-based Tokyo event loop. I haven't actually used anything else than the basic Async.io event loop and UV loop, but adding support for Tokyo and AIO-G event was trivial, so there you have it. Feel free to experiment.
And for anybody who wants to get in touch with you or follow the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And my pick for this week is going to be the movie Thor Ragnarok. I just went and saw that last night in the theaters, and I thoroughly enjoyed it. It's a good story with a lot of humor throughout, so it's just a really enjoyable film. So for anybody who's into any of the Marvel movies or that particular genre, it's well worth the watch. And with that, I'll pass it to you. Do you have any picks for us this week, Alex?
Yeah, actually, a recent favorite of mine would be music from the Two Steps from Hell band, which is actually a Norwegian duo who have moved to the United States. They make the kind of music you hear in really epic movies. Think of Pirates of the Caribbean. That's the kind of music they make. It's really, really epic and always inspiring.
Yeah, I'll definitely have to check that out. That sounds interesting. There's a lot of really great groups that have come out of the Norway and Scandinavia region, so I'll have to take a look at that.
Mm-hmm.
All right. Well, I really appreciate you taking the time today to talk to me about the work that you've been doing with Asphalt. It's a really interesting project and one that I hope to see succeed in the long run. Seems like it's going to simplify a lot of the work that people are going to be doing going into the future, particularly as they start embracing more of the async capabilities. So thank you again for your time, and I hope you enjoy the rest of your day.
Thank you very much for having me. And as a last note, I know that Async.io can be difficult to grasp. I don't blame anybody for telling that it's difficult to start with, but I really hope that people can overcome this obstacle and really start embracing async code, because when you get it, it's really rewarding, in my opinion. So I really welcome anybody who wants to try Asphalt. I have many channels through which you can get help. Gitter would be the best option, and there's also IRC, and of course the issue tracker on GitHub. So just drop by and ask anything you like, and thank you.